Hey everyone, Lucky Arduino here. Today I'm going to showcase one of my new projects, a calculator using my Arduino microcontroller, an IR remote, and an LCD display. I've already shown how these components work in the Arduino tutorials section of my channel, so go ahead and check that out if you need more context as to how these work. But this project is more a continuation of those principles and a lot more coding involved in the project. So if you would like to see exactly how I made this, let's get started. So here's a small demonstration of how exactly this works, right? So here I'll put the Arduino remote on the side. So it's prompting me for my first number, right? So let's put in 52, and then we press the stop button to transition to the next state, which is the second number. Let's put in 63. All right, and we press the stop button again, and this transitions to the third state, which is operation. Then we put in add, subtract, divide, or multiply. Right, let's add the two together, and that yields 115, which is the correct answer, by the way. And here we can press the power button to clear the display and all the operations involved, all the numbers, and we start back from scratch to do another operation, right? So let's do another one real quick. Let's do 12 and 7. And what we're gonna do here is divide. So you see, the Arduino is capable of dividing these numbers up to 2 decimal places, which is fairly good for a microcontroller such as this. And let's go ahead and press the power button again and restart it. Now you might be asking, what happens if there's something that's not allowed, such as dividing by 0, right? Usually in a mathematical context that results in undefined, but let's see what the Arduino does. Let's pick an easy number like 5, and the second number will be 0, right? And if we divide inf, and basically this is short for infinite, right? Because the Arduino cannot find an integer answer for this, it just results in undefined, or in this case, infinite, right? Which means the same thing. It's interchangeable in this case. And let's go ahead and press the power button. So that was a quick demo of how exactly this calculator project works. Again, if you want more context as to how these parts work specifically, check out the Arduino tutorials, but let's get into some of the coding behind this. All right, so a lot of this is going to be code that we have seen before on this channel, but a lot of it is new as well. And I'm sure all of you computer science enthusiasts out there have made some sort of project with a calculator before. Even I have done one in my AP classes, right? So, but this is a little bit different because it's with Arduino and I've integrated components into it. It requires a little bit more problem solving and decision making when doing this type of project. And you'll see that as we go. So here we have the libraries that we need for the LCD and the IR remote. We're gonna initialize the LCD with this formula, liquid crystal, boom, 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 boom. These are all the ports, IR port for the IR receiver. Then we have a couple of variables that we're gonna use to print to the LCD display, track some numbers and whatnot. All right, now we get to our void setup. This is the thing that happens at the start of the program and doesn't happen again. Here we start the LCD, we start the serial monitor, which we're actually not using, but I used it for testing earlier. And we have the IR receiver starting. So first we have the loop, right? So every time this loops, it needs to start at a baseline. And so that's what I have here. The LCD is completely cleared. All the variables are set to their first value, which is either nothing or 1 for this count variable, right? And so this starts the calculator off at a very baseline. Then we have while count equals 1. So this is a loop inside of a loop, and this loop, it will stay while count is 1. It will stay in this loop, and then once count goes to 2, it moves on to the next thing. So while count is 1, this is the first state that I talked about. We print first, right, to ask for the first number. Then we wait for a response. Then once something's clicked, we add the response to str1. And str1 is basically the string that is being printed to the LCD display. And here, numcheck is a function that I have created, which we will see later. It's at the very end, but it's very important to this program, right? Basically what it does, it takes the raw data from the IR receiver in hexadecimal and turns it into a string that we can use to print to the LCD display. Then we print it to the LCD display, obviously. We delay to make sure there's no glitches. Then we start the IR receiver up again and get it ready for the next input. Here we check if the IR receiver did not press, if the IR receiver pressed the func stop button, right? If it pressed the func stop button, which is enter, that means the number is over. We do not need to worry about the number anymore. And so we stored the final string of the whole number and turned it into an integer, right? And that's exactly what we're doing here. This allows us to store the string that we originally had into a number so that we can add it later, or subtract, or multiply, or divide. Finally, we end with count plus plus, which increments the count by 1 and breaks out of the while loop. All right, now we move on to the second state, which is pretty much exactly the same, except for second and all of this stuff where we track num2. Because we want the second number, we have to create a second string and a different numcheck for this, right? Everything is different, but we're doing the same exact process. Then count plus plus, after the func stop button is pressed and all the numbers are done. Then we transition to the third state, where everything's cleared and we ask for the operation. We wait, then we check for the operation. Symbol check is another function that I used, which we will see later. Then basically what it does is it checks for multiply, divide, addition, or subtraction. Then we print that to the LCD display. We delay, and then we check again for func stop. If that is pressed, it will clear everything, calculate the answer, right? And this is the third function that I used, calculate the answer. Then we print power to clear, right? And so what this does is it prints the answer on the first line, then on the second line, it prints power to clear. Once that is done, the count increments and we go to the fourth state, which waits for the power button to be pressed. If it is pressed, count will increment one more time. It will break out of the while loop, and you can see there's nothing left here after this one, right? So that means since we're in a big loop function at the beginning, it will loop back to the very beginning. So if power button is pressed, it loops back to the beginning and everything is erased, right? And so that's basically how I made this calculator project. But I had to make use of a couple of functions to make life easier for me. So here we have the calc function, which calculates the exact answer. So we check if the operation equals plus, then return I1 plus I2, right? And then we check minus and multiply and divide. And for divide is a special one. You have to make sure that you make it double I1. You're casting the int to a double to make sure that the stuff after the decimal point doesn't get truncated or removed, right? You're making sure that all that decimal point stuff, like let's say 12 divided by 5 is 2.4. You want to keep the 0.4 part of it. So you have to make it a double. And that's basically how this works. That's the function that we use once to check for the answer. Then we use numCheck as many times as we type in a number. We have to do this. So here's a long, right? So the data that we receive from a hexadecimal is a long, technically, right? This long thing here. Obviously, it's not named the best way. It should be like hex or something, I think. But it's a long, and so that's what we're checking for. If it's this long, then we'll return 0. If it's this long, then it returns 1. And basically we check for each number on the IR remote. If a number is not pressed, it will return nothing. And this is important because we don't want anything to be added to the string if a number is not pressed, right? And so we use this a bunch of times whenever the person types in a number. It's very important. Then here we have our final function, symbol check, which also relies on the long, right? So if this is pressed, right, then we return plus. If this is pressed, we return divide, and so on, right? And this turns that hexadecimal into an operation string that we then use to print to the LCD display. And then later we use the calc function with that operation from the original one to find our answer. And as you can see, the string version of the operation is already there. That's exactly what we need. And that's exactly what comes out of the symbol check function. So these functions that I used throughout my project are extremely helpful for me, and they're a new topic that I haven't introduced on the channel yet, but they're essential to a good coder's arsenal. Alright, I just want to highlight some upsides and downsides before I finish off the video. So an upside of this is that it's really interactive, right? Compared to one where you could just code and type in some numbers and get an answer, this one really, you get to use this remote and see the results of your calculator right there in mechanical format instead of digital, right? And that's really interesting to me. One downside I would say though is that I couldn't get decimal numbers to work, as in you can't do 5.2 plus 2.4 on this calculator, because when I did my conversions from string to integer, I am converting to an integer, right? A decimal point number in this coding format is either represented as a float or a double. And converting it to those is a little bit more tricky than just a simple function as an integer. So I opted out of doing all that extra coding and just wanted to give you guys really the bulk of what exactly this project was about. And it was to make a simple calculator that could perform decent operations without being super over the top or complicated, right? And I think I really encapsulated the essence of that in this video. All right, thank you guys so much for watching. As always, don't forget to check out my website for more information, as well as all the code for this project. See, if you want, you can edit my code and make it your own, and make it even better if you wanted to, right? This was just very basic, and if you wanted to make it super advanced, you could. Also, don't forget to check out the rest of my channel for more information on how these components and coding principles work. As always, don't forget to like and subscribe, and I'll see you in the next one.